A titration is the process of carefully measuring and controlling the addition of a solution called a titrant from a burette into a measured fixed volume of another solution called a sample in an Erlenmeyer flask. So, some new lingo. This is called a burette, okay? So, you see, it starts there at 50 and goes up to 0. So if it's at the 0 mark, okay, then you know how many milliliters you have, and as you go down, you can measure the differences. Now, when it's turned like this, it's just like the gas that it will come out. When you turn like this, it will come out. If it's like a little bit like that, it will go even smaller here. Okay? So this is a burette. Say it. Burette, 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 burette. What goes in here according to this definition? Titrant goes into here. So titrant, titration, okay? Titrant goes in here. Then that's the known concentration goes in here. So when we think about it, we have the titrant in the burette, a sample solution in an Erlenmeyer flask. So titrant is in burette. Plus a sample solution, that's the unknown concentration. And in the sample solution, you have the indicator, the pH indicator. So I'm going to add a little note to this. So the titrant in the burette, this is the known concentration, and the sample solution is the unknown. Okay, so when you think sample, think that's what you're trying to figure out. Okay, so sample is the unknown. Oh, whoops, there was a thing there. The main goal is to find, oh, do you guys have this? Is a thing? Okay, the goal is to find the unknown volume of titrant in order to solve concentration of sample. Order to solve concentration of sample. So it's like you try and find how much titrant is needed to complete the reaction. So once it's like all done, then you know how many moles is needed to complete the reaction, and you can find the unknown concentration. So, for example, in solution stoic, sometimes you don't have enough information to solve the problem on paper, so you need to do an experiment. So, for example, say we have 10 milliliters of acetic acid, and it reacts with 0.6 mole per liter sodium hydroxide. What is the concentration of the acetic acid? Can you figure it out? No, you don't have enough information. So if we wrote out, we have our sodium hydroxide plus our acetic acid. NaCH3COO, whatever. We are told information of this is C is 0.6 mole per liter, and we know the volume of this, and we're trying to find this. Well, I can't do very much. I can't go very far. I need to find the volume of sodium hydroxide needed first so I can find the moles and apply it here. Okay? Blah, blah, blah. Did you guys write that down? Do you have space to write it down? Or did I do it for you?
It's already in there.
It's already there? Okay, thanks. And I put it in apparently. Okay. All right. So you need this volume in order to solve the problem. All right, so when we look at our equipment, a solution called the titrant is transferred from a precisely marked tube called a burette to an Erlenmeyer flask containing the sample and an indicator. Any indicator like methyl orange, bromothymol blue, phenolphthalein is used because a sudden change in color indicates the completion of the reaction. So in your diagram, so note the sample solution is usually measured out at 10 mils. It's just kind of standard. So in your diagram now, let's label it. This is the burette. It contains the known titrant, or it contains the titrant, which is the known concentration. And down there is the flask, contains a sample and an indicator, the unknown concentration. So let's stop there for notes, and I'll just tell you a couple things about the equipment. Well, what time do we have? Oh, I guess we have 10 minutes left. I'll tell you about the equipment.